Today I wanted to explore some variations on one of my favorite projects, physics with Rapier. We're going to add a loaded model. I see that duck floating around in there. We're going to add a bunch of different shapes. We're going to modify the physics to work with those shapes, add camera controls, better mouse interactivity. Yeah, so lots of different stuff to explore. If you're new to Three.js, check out my course, Learn Three.js Basics.
First, I want to give an overview of where we're starting. This is usually the starting point for my Three.js projects. But today, we're starting here. Okay, so what's already here? I have initialized the renderer, the scene, the camera, and the animation loop. I've filled the scene with these icosahedrons, these balls. I've wired up mouse controls so that I can move this glowy white object around with the mouse. Then I added Rapier Physics to this, creating a collider for each one of those icosahedrons and for this glowy ball to create this effect. I kind of tweaked it until it looked just the way I liked it. Then I added post-processing to get that cool glowy effect. La la la, like so. Great. First thing I want to do is just pull out this effects processing. I don't need this post-processing anymore. And change this from composer to renderer. And the scene, hang on, let me come back over to the scene now. It looks like this. I want to add the OrbitControls. Import OrbitControls around this. So this path works because I have this set up in my imports inside of index.js here, this import map. There's JSM. What I want to do is add Rapier to this too, like so. And just take this, just kind of clean things up a little bit, make my index.html look a little nicer. And I'm going to remove that version number on there. Good. Let's instantiate those OrbitControls. To do that, I'm going to use Super Whisperer with VS Code agents. Super Whisperer is running every time I press the Option and Spacebar together on my Mac. I'm going to type Command I in VS Code and then Option Space. Instantiate the OrbitControls. Hit Enter. Okay, accept it. I only really need these guys here. And come down to your animate method or render loop and uncomment that, or just add that line. Now I can orbit around the scene. That creates a problem with the mouse position. Once I've orbited, the mouse doesn't behave like you'd expect, so we'll fix that later. I want to come into my get bodies method. This is where I create the meshes and also wire up the physics for each of the meshes. In here, I want to remove that wireframe, like so. And that should look like this. I also want to import get layer from source/getLayer.js. Now let's use VS Code agents again. Like so, Command I. Instantiate get layer in a variable called BG sprites. Kind of trivial. I could have done it. Oh my goodness. That's pretty cool looking, actually. Oh, I like it. Oh, that makes me think of a really cool effect. Put a sprite inside, a parent inside of an invisible ball, and then we'll have these little puffs interacting too. Oh, that sounds cool. Stay focused. All right, so the defaults are not working for us. All right, so these defaults I think will be better. That's it for the tweaks. Now we're going to start with the variations. Okay, I want to fix the lighting first of all. To do that, I'm going to import the Ultra HDR loader. Import Ultra HDR loader. And thank you, Copilot knows where that is. like so. And let's say, oh, why did that happen? Why is it mad about that? Oh, because I need to update the version here. Let's make this 71 instead. That version of Three.js doesn't have the HDR loader. Okay, good. Right before I instantiate that mouse position, let's do this. Control I, and Option Space. Instantiate the Ultra HDR loader and load an image. All right, so that's how that works. Let's just replace this placeholder path with, I think I'm calling it env/this. Give her that HDR. Texture mapping, let's just see how it looks. Yeah, look at that. Now I'm using an HDR image as the background and the light source. Here's what it looks like without the background. You could just see it working as a light. I think it's so cool. The agent created this HDR loader and then loaded the image, setting the mapping to this equirectangular reflection mapping, and then setting the background and the environment of the scene. Okay. I'm going to get rid of this hemisphere light now. How does that change it? It's just a little bit different, I think. Okay. Let's swap out materials on these guys. Right now they have a mesh standard material. Let's make it a mesh physical material. Is there any noticeable difference? Don't think so. Now I want to set the roughness, and I want to set the metalness too. See how that changes the appearance. Yeah, if you set the roughness to 0, it's going to be 100% reflective. There'll be little shiny balls if you turn off the flat shading, like so. I'm going to leave flat shading on and turn up the, let's see, if you turn up the metalness, they'll be darker and more interesting looking, like chrome. Little chrome balls. Okay. Let's leave them as chrome balls and modify the roughness so that's like a blurry reflection kind of. Also interesting. All right, so hang on. Roughness. Let's make it 0.5 and leave flat shading on. Yeah, leave metalness on. Okay. Oh, a bunch more primitives. Here's what that looks like. Let's ask Copilot to do it first. Create an array with a bunch of different primitive geometries in it. Great. Now, inside of my getBody method, instead of just instantiating this icosahedron, we'll say get geometry, and we'll pass in the size. All right, let's see what you got. Yep. Oh, I don't need all this crap. Return geometry, yes. Don't need any of this or the translate. Scale, we could use. But I think I'm going to leave the scale off. Like, who cares? Oh, look at all those geometries. This exposes an interesting shortcoming of our setup that we're going to see that we're going to fix in a second. And that is there's no rotational physics. It's all just positional. None of these guys are rotating. Let's fix that. I want to modify the physics. Here I'm where I'm up. This is the update method for each one of these little objects in here. Okay, here's where I set the position, and I add the force to pull it toward the middle of the screen. Let's also update the velocity. Excuse me, the rotational. Let's see if GitHub Copilot can do it first. Add rotational physics. Okay. Well, let's try it anyway. No. Oh, shoot. That's it. It works. I like it. Okay, now debug mode. It's already looking pretty cool, but they are definitely overlapping in an unnatural way. So come in here. Inside of index.js, first thing I want to do is create a points object. I'm creating 3.points with a points geometry and a points material. I'm going to use this for the debug view. I'm going to add it to the scene. And now inside of render debug view, just grab the world.debug render. As you recall, the world is here. It's instantiation of Rapier world. And then I'm just going to set the position attribute and color attribute of these points. Add that to our method render debug view. And now we can see what the colliders look like. And you can see they don't really match up very well with our primitives. Let's modify these so that they're semi-transparent. Transparent is true. And opacity is 0.5. And you could see that's what that looks like. Okay, so the solution I suggest for this is instead of just using the same collider for every object, let's customize each collider so that it fits the mesh. Convex hull is what that is. I think I could just type convex hull. And what it wants is points. And those are const points are equal to the geometry. Actually, just the geometry needs to be above. Like so. Now I can say geometry.attributes.position.array. Let's see what happens when I do that. Oh, look at that. It's the performance just dropped significantly. Right? Everything's moving a lot slower. But now you see that the colliders, and let's turn off the debug view momentarily and make our objects opaque again because it's impossible to see what's happening when they're transparent like that. Now they collide properly. And it's really slow. And I think that's because of some of the geometries I'm using. Let's import the rounded box geometry. Like this. And I want to use that instead of box. And I'll just use these defaults. And I broke it. I don't know what the hell you're talking about here. Do you see the rounded box geometry? I don't see it. Let's isolate it so we can see it. There they are. Oh, look at that. I think these are reversed. I'm not sure. Let's figure it out though. Uh-oh. That's unstable. We might want to play with some damping to stabilize this simulation because it's pretty wild right now. Okay, I'm hoping that'll stay stable. So, what type of parameters does this constructor need? And it'll tell me height, width, dates, and segments. I think it's inverted the radius in the segments though. So let's try this. 2 and 0.2. Oh, wow. I didn't expect that. 0.1. Yeah, that's it. It inverts those for some reason. Add a couple more segments, and those look pretty good. Is it slow though? Yeah, it's a little chunky, isn't it? So let's reduce the segments down to 2, and Bob's your uncle. Let's add in torus geometry. I think that's got way too many. Let's make that 32. Oh, that's nice. They're way too big though. 0.3 and 0.15. Is that better? I think it's better. I like the tetrahedron geometry and the torus knot geometry. Let's make that smaller. And 0.15. This is way too heavy though. Make it 64 and 12. It's reducing the poly count. And if we turn off flat shading, it's going to look a little bit nicer. So I'm sort of making a trade-off between the resolution of the geometry and the appearance of the render. Aren't those just too big? They are. It's 0.2 and 0.1, 0.2 and 0.1. So a lot of tweaking here. Oh, that's better. Yeah, look at that. Oh, I like it. Great. I don't really need this, do I? All right, I want to improve the mouse interactivity. Right now, if I pan around the scene using the orbit controls, it kind of ruins the mouse interactivity. Okay, let's fix it. We've got this mouse position already defined. What I want to do now is to add an invisible plane, which we're going to collide. We're going to use a raycaster to collide with. It sounds complicated. Let's just step through it, step by step. Create that mouse plane, just a plane geometry and a material, which is totally transparent. Let's make it semi-transparent. Actually, I'll do that in a second and add it to the scene. We're going to add a raycaster and this vector 2 for the pointer pause. Okay, we're going to create a new method called handle raycast. Inside it, we're going to cast a ray from the camera to that pointer pause we set in our mouse listener. And then we're going to call this intersect objects, raycaster.intersect objects. Then we're going to call intersect objects, passing in the mouse plane. So if our mouse cursor point has intersected the mouse plane, if it has, then copy that into mouse position. And let's see what that looks like. It looks like that. Because inside of get body, there's this funky thing going on here where I'm not setting the Z position, I think. Oh, I'm also modulating it like this. Let's reduce that. And mousepause.z. Okay, let's see how that looks. It doesn't really look better. I'm not sure why that is yet. Let's keep going. Inside of handle raycast, I want to orient the camera. I'm going to orient this plane so that it's always facing the camera. To do that, I'm going to create this vector, camera direction, and then tell the mouse plane to look at the camera. Okay. Save that. And now wherever, oh, that doesn't work yet. Oh, because I'm not calling this method. Let's call handle raycast inside of our animate method. Where are you? Here you are. I mean, here, it doesn't matter where. Now, as I rotate through the scene, see how the camera, you see the background sprites kind of moving around, but the plane stays oriented toward the camera at all times. All right, I want to fix that mouse pause. Oh, look at this. Let's get rid of that. That's probably ruining it. Now, look at that mouse. That little ball, the mouse ball. As I rotate through the scene, hey, let's make the sprites a little more visible. Get layer. I could also do this. So this is intended to be used this way, where background sprites where I actually tell it the options I want, like opacity is 0.2, for example. They're a little more visible now. And since we did that, let's go ahead and hide that BG plane. We don't need to see that anymore. There we go. As I rotate around, it still interacts. This last section, I want to clean things up a little bit, only keeping the geometries I really want. And I want to load a model as well. I'm going to load a GLTF model of a duck and then integrate that into our scene. Import the GLTF loader from there. Great. I'm creating a method called load GLTF models. I've instantiated my GLTF loader and I've got my single path here. Inside of this load GLTF models, which is an asynchronous function, I'm going to create a new promise for every item in that array. In this case, there's only one. Here's the load call, and I'm going to traverse the model looking for a mesh. If I find a mesh, I'm going to grab its geometry and push it into that geometries array I created earlier. Lastly, I'm going to call that with the await keyword. And let's see what happens. Oh my gosh, look at the duck. The duck is too big, so we can scale that down before we load it. Child.geometry.scale. 0.1's a little bit on the small side, but 0.6 might work. I like 0.6, but it's going to be 0.5. Now I've got an external model. Let's add some interesting colors to our project, and then we'll wrap it up. You can get your colors from anywhere you like. I like to go to a website called coolers.co. And I like to look at the trending palettes and just pick one. Let's do that first. How about this one here? I'm going to go copy this URL. Where is it? Copy URL. And let's see if the VS Code agent can do this for me. Convert that URL to an array of hexadecimal numbers. That looks pretty good. Here down here in our getBody method, I'm setting the color of the material. I'm not. Well, now I am color. Do it like that. I prefer this syntax. Let color equal boom. And let's see how that looks. Not too shabby. Let's pump up the or pump down the roughness. What do you think? Here's some other color palettes. I think it's amazing. I love it. I love that color palette. Let's call these colors. So there's uniformity. Here's a different one. I think this is my favorite. There you have it. Whew. Right? A lot going on there. Thanks so much for tuning in. Leave a comment below if you have a question or if there's something you'd like to see. I'd love to hear from you, and it really helps my channel grow when you interact with my comments. All right. Thanks so much for coming by, and I'll see you in the next one.